Can anyone confirm if the audio is fine before I get started? Okay, so thanks, Dungeon Master. I will start now. So hello everyone. Today I would be discussing the solutions of problem Leetcode biweekly contest 122. And after the contest, I can take some other questions or doubts if there are some. And like this contest went pretty good for me. I was ranked fourth in the contest. And let's get started. First problem says divide an array into subarray with minimum cost 1. Like the harder part was the hardest problem of this contest. You are given an array nums of length n. The cost of the cost of array is the value of its first element. For example, the cost of 1, 2, and 3 is 1, while the cost of 3, 4, and 1 is 3. You need to divide nums into k disjoint continuous subarrays and return the minimum possible sum of the cost of subarrays. Some examples like 1, 2, 3, and 22. It says the minimum cost is 6 because we can divide the array as 1, 2, 3, and 12. If in that case the cost is okay, like it says the best possible ways to form three subarrays is like we take 1, 2, and 3 and 4 and at the total cost of 6. Like the other ways to divide this array is 1, 2, 3 as second array and 12 as the third. In that case the total cost will be 50. And if we divide the array as 1, 2, 3, and 12, the total cost would be 16. And similarly, the other examples. So, like to summarize the problem, it says like they have defined a cost function for an array. As the value of the first element. And then it says you are given an array A. So, on something like this, you will have to divide this array into three different arrays. And you have to divide it in such a way that the total cost is minimum possible. Like, for example, one way to divide this array would be this. In this case, the cost would be A1 plus A4 plus A6. Like the first element of the first array would be A1, the second element would be A4, and like third element would be A6. Another possible way to divide this is like we take A1, A2 as the first element, A3, A4 as the second element, and A5, A6 as the third element. In that case, the cost would be A1, A3, and A5. And you can try out different possibilities over here. And like in this case, the constraints were very small, less than 50. So you can also do a brute force. Like you know that like you can know that the because you have to take all of the elements. Like the first element of the first subarray would be A1. But you can run a for loop to find like where you should start the second and third element. For example, you can run a for loop for I equal to 2 to n, for j equal to I plus 1 to n. And now you can see like the cost over here would be like 1 to I minus 1 is the first subarray. AI to j minus 1 would be the second subarray. And AJ to last would be the third subarray. So in that case, the cost is A1 plus AI plus AJ, assuming one base indexing. Sorry. Like I will repeat again, like it looks like I missed this one. Like we can run a for loop for I equal to 0, for j equal to I plus 1 to n. Then in that case, your subarray A1 to I is the first subarray. I to j is the second subarray. And AJ to n is the third subarray. So in that case, the cost is A1 plus AI plus AJ. And you can take minimum of all of them. And if we go with zero based indexing, you can assume that the array is 0. Like there is a simpler solution for it, but I will keep it for the when I'm discussing the last problem. And looking at the code for it, like you can say like the first way to would be to like the easiest way is you can take the first element as the first array, second element as the second array, and everything else as the third array. Like doing this one should solve the problem. Like we can do one more smart thing over here. Like you will notice that A1 always comes in the cost, and you have any choice to do anything for the remaining element. Like you can decide whatever you want. So what you can do is in A1, A2 until AN, find the minimum element and second minimum element. And I claim like using this greedy, we can just return A1 plus minimum plus second minimum. Like if the minimum, like for example, the array looks like, let's call mn2 as the second minimum. Like if the array is like this, a some elements, minimum some elements, minimum two some elements, or the other choice would be a minimum two first, then minimum, then remaining. Assuming that you are finding minimum for all the elements after the first element, then in that case you can choose the array as this. And if it's the second case, you can choose it like this. So like the other way would be like just sort, you can sort the second array although it's not strictly required, and then you can try to find the values for it. So like what you can do is a dot remove the first element, then sort the remaining array. Like there are other ways to do it with big of order and approach as well. Like if you do it like this, then you can do this one will also work. And now you can do one more thing. You can maintain two variables. Let's take as infinity. Like the sorting would be n log n, where n is the size of array. You can also find minimum with one iteration of the array as well. If current element is less than minimum, then second minimum is current minimum, and minimum would be current. Otherwise, if current is less than second minimum, then minimum remains minimum, Like although it doesn't do anything, current minimum becomes current element becomes the second minimum. Then you can print first plus minimum plus second minimum. This will also give an AC for this one. Okay, looks like so. So like these were some ideas. The critical observation, like we can, after we have to always check the first element, and we can take the smallest two element for the remaining two arrays would be critical for solving the fourth problem. Like the harder version of this problem that was asked in the contest as the fourth problem. So like I will continue discussing the remaining part when I go to this problem. Now the looking coming to the second problem. Like it says find if the array can be sorted. You are given zero index array of positive integer nums. In one operation, you can swap any two adjacent element if they have the same number of set bits. You are allowed to do this operation any number of times, including 0. Return true if you can sort the array, else return false. And now let's look at the sample as well. Like in the first sample, like let's look at first what does it mean by set bits? Like what is set bits? Like problem does not explain it anywhere. So like set bits is like, let's say you have a number, some different numbers, 2, 4, 10, 13, something like this. First represent it in binary, like 2 would be 1 0, 4 would be 1 0 0, 10 would be 1 0 1 0, 13 would be 1 1 0 1. So like first, if you want to count the number of set bits for given element x, first write it in binary and then count the number of ones in the binary. In this case, set bits is 1. Here the number of ones is set bits is 2, 1. Here the number of set bits is 2. Here the number of set bits is 3. And like there are many ways to do it. One is you can run a for loop, find binary notation, then count ones. The other is you can use some built-in functions. Like in C++, there is built-in count. 8 seconds. Like let me. Like I just forgot. Like built-in pop count is one method. Like use this method to count number of bits in C++. Like, or you can just refer this article. Like how do you really count the number of set bits? And in Python, you can use the like in Python you can use bin method. If you pass it on, then it returns the binary representation. So you can run build x dot count 1. This will also return the number of set bits in Python. So now, like first we have figured out like how do we count the number of set bits. Then the next part is like it says like we can only swap like the minimum elements over here, like adjacent elements over here. So like when we can only swap adjacent elements, the idea is we do like insert like sweep sort, or like I'm forgetting the sorting algorithm name, but I'm pretty sure like there is a name for it. Like there is a sorting algorithm for it, but I am just forgetting its name. Sorry. Yeah, bubble sort, right? Sorry. Yeah, sorry. So what we can do is we can perform the bubble sort for sorting this idea. Only thing we will need is we will need one additional check to count the number of sat bits over there. And if there are sat bits and the first one element is smaller than the other, we can do that. So like for example, like I am running a bubble sorting similar algorithm over here for I equal to 112. Take to adjacent element. If the first element is less than equal to y, continue. Otherwise, if the number of set bits are not equal, continue. Otherwise, it's possible to swap them, so swap them. At last, take the final array. Like you can do it before as well. Like first, see like how does the sorted array looks like, and at last just check like after performing the bubble sort with the additional condition that the set bits are equal, we can do that. Yeah, I am sorry, but I don't know how to code in Java, so I don't really know if there is some predefined method or not. And yeah, thanks everyone for congratulating about the rank. Well, like I generally know like how to code in Python, C++, and sometimes in JavaScript as well, and JavaScript and Go. So like that is the main idea for this problem. And like now, if we look at the sample as well, like we can look at like how does the algorithm perform on the sample. Like the first sample is 8, 4, 2, 30, and 15. Like the number of stat bits in 8 is 1, number of stat bits in 4 is 1, number of stat bits in 2 is 1, number of stat bits like 30 in binary looks like, yeah, 30 in binary looks like this. So like the number of stat bits would be 4, and the number of stat bits in 15 would be 4 as well. Like 15 looks like this. So like we can perform insertions or like bubble sort over here. Like we can first swap 8 with 4. Like the array would be 4, 8, 2, 30, 15. Then we can swap 2 and 8 as well. And then we can sort like swap 15 and 30 as well. Like yeah, the idea is we can swap these elements however we want, and we can also swap these elements however we want. And if we sort this part and this part, our final array would look like. And this is indeed the sorted array. So like that was the main idea for this problem. Now I will move on to the third problem. It says minimize the length using of array using operations. Like can I provide C++ code? Like I can code the same in C++ as well. I'm just making a copy because I don't really know this pass by reference can change the test cases on. For auto A equal to B, for auto B equal to. We first sort like without finding like how does the final array looks like. And then we can also try to do bubble sort. Like now I will check if the sat bits are not equal, then it's not possible to swap them. Like there is sorted method as well, I believe, in STL. Now I will move to the third problem now. Minimize length of array using operations. You are given zero index array nums containing positive integers. Your task is to minimize the length of nums by performing following operations any number of times including zero. Select two distinct indexes I and j from nums such that num I is greater than 0 and num j is greater than 0. Insert the result of num I modulo num j at the end of the nums. Delete the elements at the index I and j from the num. Return an integer denoting minimum length of nums after performing any number of times. So like let's look at the first sample. So like for the third problem, I will not say like you need a lot of topics, but the idea was to do it in this way. Like someone is asking, can this question be done like the 1 second? I will first take this one and like I will move on to the previous one again. So like here, let's take the first sample. So like if we look at the idea of what's happening over here, like for example, let's take some array 2, 3, 5, 7, 10. Like we can take any two numbers, however we want. Let's say we have taken 3 and 5, and like 3 as j, and like j equal to 2 and I equal to 3. Now we first find like how does num I minus num j looks like, which is 2. Now we can delete these two elements from here and add this result at the end of the array. So our final array looks like 2, 7, 10, 2. If you notice, the size of array has decreased by 1. Now let's say we choose two numbers, 7 and 10, where I is 3 and j is 2. And then we remove these two elements from here and add 10 modulo 7 equal to 3 at the end. So our new array would look like, and we can keep doing it. And you notice that whenever, like now let's say we have chosen 2 and 3, and our array becomes 3 modulo 2 equal to 1. And now we can take these two elements and our array would become like only 0 will remain at the end. Similarly, looking like let's try to solve the similar problem for 2, 2, 4, 6, 3. Let's say we have chosen 2 and 4, and 4 modulo 2 is 2. So our new array becomes 2, 6, 3, 0. And in this case, now we cannot choose 0 again because we have to choose positive numbers every time. So let's say we have chosen 2 and 6 again. Like 6 modulo 2 is 0. And we add 0 at the back, our array becomes 3, 0, 0. And notice that we cannot reduce it even further. 3. There is, so now I am claiming there is one way to get the final array of the length as 3. I am not claiming that this is the minimum possible answer. Like let's say here it says find the minimum possible values over here. So now we need some, like this is how the problem is working. Like now let's try to find some observations over here. First thing, notice that like there is no condition between I and j over here. Only thing is like both the values should be greater than 0. So like I can be less than j, or j can be less than a. Both of them are allowed. And now notice like what does the value of a b looks like. If a is less than b, then a modulo b would be some value, which would be less than, which would, oh, 1 second. The key idea for this problem was observing like what is the value of A modulo B. If A is less than B, then A mod B remains A. And if A is greater than B, then A mod B is some value which is less than B. So like these are the two critical properties over here. Now the main idea here is like let's look at the minimum of the array. If you take some element AI and do it with minimum, then you will get an element less than minimum. And if you take any other element, minimum less than AI, assuming that AI is greater than minimum, and the minimum would remain same as it is. So like first look at this one. Like we have this array, let's say A1, A2, A3, A4, AN. And let's say A3 is the minimum. And let's say AN is the value which is greater than minimum. And if you choose this operation, it becomes minimum again. So like you would be deleting these two values and adding minimum at the back. And if you realize over here, like you can delete any element greater than min while keeping the remaining elements. Like basically you can delete any element which is greater than 0 freely. The only issue is like if we do minimum modulo minimum, we get 0 and next time we cannot use 0 again. So like if we look at the original array, and if say that like 5 elements are equal to minimum, then all the other elements by taking I equal to index of minimum apart from those minimum elements. And like after deleting all the elements other than minimum, you will, the remaining array would be minimum, 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 minimum. Then you can delete two elements in pair. Like you can delete these two to get 1 0, these two to get 1 0, and like this one will remain. So like at last 3 would remain. So like to summarize the idea again, like these are the critical properties. If you look at the value of A mod B, if A is greater than equal to B, then the final value is less than B. But if A is less than B, then A mod B remains A. Now this gives us an idea, like if we take the minimum element as A and any element greater than B, greater than minimum as B, then your final, that modulo will also give you minimum. So you can just forget that the element which is greater than minimum exists and you can directly delete it. So now if you say, let's say if you have 5 elements as the minimum, then you can definitely get an array of 3, like by deleting 2 elements in one go and like whatever it remains. So like one possible solution is like this is definitely, there is now what we have decided found is like this is one possible way to find over here. So like I am not fully done with all this. So here, for example, if you can first take, so you first delete these two and add 3 back. Now you can take 3 and 6. So like you can get an array of 3 and 3. Now you can take 3 mod 3 as 0, and like the final value would be 0. So like now one more idea over here. Like this is an upper bound of the minimum possible value. Like we can do something better than this as well. Like so far we have used the first property, and our claim is like there are f values which are equal to minimum, then our answer can be ceil of f by 2. But if we haven't used the second property yet, like let's say we have found some other property, some other value, like using the second one. Let's say we have found some values which is greater than, like some value g which is greater than minimum, such that g mod minimum is not equal to 0. Then notice that whatever value x is less than minimum. And if you are able to perform an operation like this, then like this x would be the new minimum, and the number of times it appears is 1. And now using this x, you can freely delete all the other elements. So like this is the main idea. To summarize, like if f is the frequency of, then you can delete all the elements greater than minimum by performing operations like this. And at last you will have f elements equal to minimum. And now you can delete them in pairs to get an array of ceil f by 2. And like one critical idea, yeah, corner case I am saying over here is, like if you can somehow reduce the value of minimum, like if you find some element ai mod mn which is not equal to 0, then you can you first perform an operation like this to get a new minimum, then with frequency 1, and then use this new minimum to solve it with the previous algorithm, and ceil 1 by 2 would be 1. So in that case the answer is 1. So I will jump on to code for this one. Yes, new minimum will always have frequency 1 because like this is the element you are getting. So like the code for this one is, you first find the minimum of a, then the first part is you iterate over all the elements of it and take x modulo mn which is not equal to 0. And like this element would be added with frequency 1. And now using, and at last you will have only new minimum remaining, so return 0. If this is not possible, then count the number of times new minimum remains. And at last return ceil. Yeah, right. Now this is the reason why just iterating over all the elements is also enough. Like there are, like Vishnu is asking, what are the topics names for the third problem and how to approach such problems and practice them. Like I would say, like for the third problem, you will have to look at identities and try to find observations which can help you solve. Like there is no specific, if you look at the code, there is no data structure involved for this problem. And like I think Sachin asked, we do this question in order of n? Like I think that was for the previous problem. And previous problem, I don't think you can do it in order n. It's possible to do it in order n because like the minimum time complexity required to sort an array is n log n. And now for swapping, you have one additional condition over here. Like apart from swap and everything, like to make an array sorted, you have additional condition that the set bits should also be one equal. Although looking at the constants, like values are less than this and this, like you can try to do some frequency sorting or any other algorithm like that, like frequency sort or some other sorting algorithms, and try to solve it. Like I can, like my solution is n square, but I can definitely solve this problem in n log n using some disjointed data structures. Okay, can you please quickly summarize the question 3 code? Yeah. Like the question 3 code, like we had two observations first. Mhm. Like if a is less than b, then a mod b is a, and if a is greater than equal to b, then a mod b is a value less than b. So if we always use the first identity with a as the minimum value of the array, then you will delete one of the minimum element and the other b you have chosen and add one more minimum value to it. So like the here it's equivalent to you are deleting the element greater than minimum. So this gives an idea, like we can delete all the elements which are greater than minimum using one of the minimum. And once only minimums remain, yeah, all the elements of the array are equal, then you can try to delete two elements in pair such that the minimum mod minimum would be 0. So you won't be able to choose it. So you can try to delete element 2 at a time. So like this gives us an observation. Let's try to make it such that the minimum appears only once in the array. In that case, we would be able to delete all the elements in the array. And after jumping at it, like looking at the code, I first found the minimum element of the array. Then I iterated on all the elements of an array to check if we can find x mod minimum which is not equal to 0. In that case, my claim is like x mod mn would be the new element which is greater than, and new well. So like now using this new well, we would be able to delete all the elements. So return 0 in this case. And if we are not returning anything over here, then we maintain a counter. We run it all the elements and we can count like how many times the minimum element appears. Count them, and I'm returning it in pairs. So seal count by 2 would be my answer. So like I will move on to the last problem now. Like if there are no other questions on the first three problem. Why seal? So let's say you have an array like this 5, 5, 5, 5, 5. Now you can choose these two arrays to make a 0. You can choose these two values to make a 0. You can choose these two to make a value 0. So if there are 6 elements, you can make 3. But let's see what happens if there are 7 elements. You can use these two to make a 0. These two to make a 0. Now your array is 0, 0, 0, 6. Now you cannot choose 0 as one of the elements. So like you will be remain stuck with 6 over here. So if total elements are odd, you will have one extra element. And if total elements are even, you will not have any extra element. And like which turns out to be equal to seal. Now let's move to the last problem. Like divide an array into subarrays with minimum cost. The problem is same as the previous first problem. You are given 0 index array of integer nums of length n and two positive integers k and distance. The cost of an array is the value of first element. For example, cost of 1, 2, 3 is 1 and cost of 3, 4, 1 is 3. You need to divide nums into k disjoint continuous subarrays such that the difference between starting index of second array and starting index of the kth subarray is less than equal to distance. In other words, if you divide nums into subarray a0 to I minus 1, I1 to I2 minus 1 and ik minus 1 to in, then ik minus 1 minus ia1 is less than equal to distance, and return the minimum possible sum of cost of these subarrays. Like similar to the first problem, here instead of dividing it into 3 arrays, we can have to divide it into k arrays. This is one possible. What it says is like starting index of second array and starting index of last array should have a distance less than k. So like let's take some live example. Like the first array is 1, 2, 3, let's say. The second array is 3 to 6. Third array is 4 to 6, sorry. Seventh array is 8 to 10. And the last array is 18 to 16. Let's say we have to divide k equal to 4. So we have to divide it like this. And let's say distance is 5. Then the second starting index is 4. And the kth starting index is 11. Then 11 minus 4 is 7, which is greater than 5. So this is not a valid way. Had the distance been 8, then 11 minus 4 is 8, which is 11 minus 4 is 7, which is less than 8. So this would have been a valid way. And similar to the greedy idea for taking second minimum and the last minimum, what we can do is here we can maintain some sliding window. Like we have to always take the first element and like, okay, should be less than distance. Okay, I haven't. It's less than equal to distance. So like what we can do is we can fix the starting index of the second element. Let's say let's say we have fixed idx as the starting element of second array. Then we know that the starting index of kth element should be less than equal to idx plus distance. So what we can do is we can look at the array up till a idx plus distance, and we can take k minus 1 smallest element. Or k minus 2 other way around, k minus 2 smallest elements from a idx plus 1 up till a idx plus distance. I will code this part first. Like I will code one algorithm which will get a TLE first. Let's call SI2 as the starting index. You have to always check the first element, and you also fix the starting element of the second element, and you take smallest element. This is the correct algorithm, but it will give TLE. So let's just submit it. Like, like I got, because like I should not, J should not go outside N as well. One second, I am expecting a TLE over here. Like we should not choose if the elements are less than k minus 2. This will get a TLE. Like this algorithm is correct, but like the constraints are up to 1e5. Had this n be less than 1e3, this would have worked. So now what we have to optimize is we have to optimize this part over here. Like if you observe B, like we delete only one element from B and add one element to B. So we can try to maintain it in sliding window idea over here. And what we will need is the sum of smallest k minus 2 elements every time. And for that part, we can use, like there are many ways to do it. Like some people use PVDS. Like PBD, like not the PBDS one. Like the idea which I have used is, like I modified my algorithm for one of the problem which exists, like running median using two heaps. Like this is one problem, you should try it out. Like if you want to solve problem like D in future. Nowadays, I maintain two heaps priority queues using set or whatever you call. And the first heap contains k minus 2 elements. You maintain the smaller of them, some of them, and the other heap contains all the remaining elements. And using that, you can delete other elements as well. So I generally use a set to maintain like heap in the sorted order. Like I am maintaining two heaps using set multi-set. Let's call it multi-set. Okay. Like, generally, I don't use multi-set, rather a pair of elements. Some rebalance algorithm like this ensures size of PQ1 is less than equal to K minus 1. If it contains and I am also maintaining like because we are running with sorry not K dist because we have to maintain all the elements in range in the dist area like distance range. So if we have came out too far, like we also delete the element which is at a distance greater than 0. And again, then the rebalance logic to ensure that the size is less than. And at last, take minimum of answers, comma. Like I am yet to code rebalance part. Like I hope multisort does not delete element with same frequency multiple. And then I can PQ2 still has elements. And let's say if the size is greater than K, then in case we have to move the largest element to PQ2. Like so if you have solved like finding median using two priority queues, like this one would have been easier. Looks like I'm missing something somewhere. Okay, yeah. Like we do not include zero over here. Yeah. Here I am erasing the element. I should subtract instead of adding. Can anyone catch some bug over here? Like, okay, yeah. Like deleting with multi-set is always been tricky. Like why is my answer? It says my answer is 4, 11, 18, and the expected is 5, 14. Like it says for the first element, the minimum cost is 4. So like the first element, like distance is 3. So minimum cost should be 5, right? Oh, right. We should not run this logic. We should do it only if like in the first element we will end up taking like only if there are at least k minus 1 elements, then only we should take the minimum. Like sometimes you may end up with bug when you are coding them again. So like thanks everyone for joining. Like there are some questions like how I am good at lead code contests. Like the thing is I started doing lead code contests recently, and I have done a lot of problems on code forces, code stuff everywhere. Like if you look at it, like I have solved these many contests on code forces and around 2000 problems on code forces. So it's mostly about practice only. Like I have been doing competitive programming for around 5 to 6 years now. So like that's how the accumulated knowledge so far and the practice so far was the reason I was good at it. And sometimes it's tricky to recognize like the older problems you have solved. Like in this case, it was finding median using priority queues of 2 queue you would, and like how continuing on that part was the way. So if there are no more questions, then I will probably call it off today. And thanks everyone for joining. If I am awake until tomorrow morning, like if I am awake during the Leetcode weekly contest, I will participate it and have a post contest discussion. Otherwise, I will. If I do not participate, then there won't be any discussion for this. And just get better at it. No, I am not Gujarati. I am from Rajasthan. But a lot of people have asked me this question, like based on like my accent, like if I am Gujarati or not. Like any recommendation for beginner to get better at this? Like my recommended way is to practice, and like the way you can do practice is like if you are specifically targeting for lead code, then you can start with top 100 lead code interview questions. This use like this, and you will have to always practice. But like one way I recommend is like people solve top 100 interview problems, top 100 easy, medium, hard problems. Like that will give you some initial ideas, and then you can continue solving lead code problems. Or like if you are a complete beginner, like one contest I recommend is Edcode a beginner contest. Like in this case, generally there are 7 problems. Like first two difficulty of first two problem is same as lead code's first problem, and then C, D, E are generally some standard problem which have already might have appeared before as well, and their difficulty is generally equivalent to third and fourth problem. And generally then F and G are like sometimes harder than lead code hard. Like how can I contact you? Like you can probably join the Discord channel I have, and there we can probably discuss if you have some specific questions or something. And like I'm hopeful that once the Discord server is active, a lot of other people would also answer the problems they have. And sir, how difficult it is to be candid master at code courses? Like I am not sure like how do I quantify how difficult it is? Like it depends. Like the correct question you might have been asking is like how long or like how much practice it takes to become a candid master. And to be honest, it also depends on like what is your background. Like sometimes some people have solved like they have some mathematical background. In that case they are faster at becoming candidate master, whatever rating you have. Like for some people, like they are just starting it out, then they will take a slightly longer time. So like there is no fixed time. Like everyone has a different journey, and based on like how much they already know is the way. Like CP is necessary, like I would try to avoid on that comment. Like if you look at it, like some companies are CP, like but I also know a few people, like if you are asking it in the placement perspective, who have only solved they have open source contribution and got placed as well. So like CP might not strictly be necessary, but it depends on your goal, to be honest. Like which companies you are targeting or anything. Like some companies started preferred asking hard problems, and some start prefer like only development. So like it depends on them. So like I will probably call it off today, and thanks everyone for joining.